now know another representation for slope. What about the equation of a line? Go ahead on your paper, write down what's an equation of a line that you use. In fact, write down two equations of a line. You know, maybe one that every linear functions in, and then one that you would use to create or discover or determine the equation of a line. We have to be able to do. We have to be able to write the equation of a line. Now, let me get my magic eraser here, and let's see what this. In fact, I should just ask you, if I use this as my slope, now, what would my line look like? Okay, let's see what we got here. Somewhere I've got it. Okay, there's that one. And there's that one. Let's see these. Are these what you wrote? Now, no one actually gave me this. What you gave me, okay, what you gave, some of you gave was, hang on a second, pull these down, make sure I've got everything erased. Okay. What you gave was y minus y1 equals m the quantity x minus x1. Equivalent? Yeah, equivalent. Okay. If you look at this one, and then you look at this one, are they equivalent? Instead of y1, we say f of c. Instead of x minus x1, we say x minus c, okay, because we're using c's here. And instead of slope being maybe a simplified one, we'd have to determine the slope, and this would be the slope. So this is no different than what you've done before. Again, it's just repackaged, okay? It's just repackaged. And so if you think this looks confusing, then write it down, make sure you understand it. Okay. Let's go on. Using the function f of x equals 4 to the x, determine the equation of the secant between x equaling 1/2 and then some other point. And I'm going to tell you what that other point is. We're going to let c be x plus delta x. And if I give you a delta x is equal to 1, that means that c has what value? Well, and x is 1/2, okay, or 3/2. Okay, so we have 1/2 and 3/2. If delta x is equal to 1/2, then what does c equal? Start with 1/2, add delta x, which is 1/2, so be equal to 1. If delta x is equal to 1/10, what's the value of c? Now here's where you might want to throw it into decimals. 1/2 is 0.5. Yeah, add a tenth, we'd be at 6/10. Okay. Well, what's happening to my delta x's here? I'm letting them. So the delta x value is getting smaller and smaller. Okay. Delta. What's happening to the other point? it's getting closer and closer to 1/2. Okay. Let's see. Did I have any others? I think I stopped with that. So let's do this. What I want you to do, it says determine the equation of the secant between these points. Now, if we're going to do the secant between, what 2 bits of information do I need in order to write the equation of a line? And don't say the output intercept. I need the, meaning only one what? There could be multiple points on a secant, but I do need a point, okay, but I need the slope. Didn't we, back here, didn't we say that to write the equation of a line, we need the slope, and then a point, the slope, and a point, C and F of C. So I need the slope and a point, any point I have. So we need to know what is the slope of the secant. How are we going to find the slope of the secant? Well, let's decide which one of these we're going to choose. Let's take this one right here with 3/2. So the slope, and here's what I do, and you're going to want to have some way of determining, distinguishing between slopes of secants and slopes of tangents. And so on my paper, I write secant down here. When I get to the Inspire, I can't do this on the graph. I can't label it on the graph. And so I just say MSEC for the slope of the secant. Okay. But the slope of the secant is, now we know it's the change of the outputs divided by the change of the inputs. The change of the outputs is going to be f of x plus delta x minus f of x divided by delta x. For our specific secant, it's going to be f of, if delta x is 3/2, I'm sorry, if delta x is 1, I forgot where my delta was, my delta x is 1, it's going to be the 1/2 plus 1 minus f of 1/2 divided by 1. So this is going to be 4 to the 3/2 power minus 4 to the 1/2 power divided by 1. Another way of writing 4 to the 1/2 power would be to write it as square root of 4. Okay, so the square root of 4 is 2. What's 4 to the 3/2 power then? Okay, because if we take 4 to the 1/2, remember our properties of exponents? If you raise a power to a power, you multiply them, so I can kind of break them apart the same way. So this would be 2 cubed, so that would be 8, subtract 1. So the slope of that secant would be 6. Am I done? Did I write the equation of the line? Not yet. Yeah, you're right, not yet. Let me move this so we can, there we go. Okay, so but I have my slope. Now what do I have to do then to write the equation of the line? Well, I've got to go back and remember how I write the equation of the line. And that's going to be y equals, and my slope, well, and let me make this comment. I don't want you to memorize this stuff. Very little that you have to memorize in here. I don't want you to memorize it. But I want you to have it memorized. You might say, well, that's the same thing. No, it's not. No, it's not. If I tell you to go home and memorize something, you sit there for maybe half an hour going over it, over it, over and over it. You memorized it. but you don't have it memorized except for that short period of time. I took French as a minor in college. I know exactly what I'm talking about because I did that with the French vocabulary. Do I know much French vocabulary nowadays? I committed to memory for those vocabulary tests, though. Okay, so, but when you have it memorized, then it's there. Now, how do you get it memorized? Well, you write it, you write it over. Every time you use it, you write it. So for us, we're going to say, okay, what is my equation to secant? It's going to be f of x plus delta x minus f of x divided by delta x times x minus c plus, wait a minute, how do I want to finish that? Yeah, we'll do that way, f of c, because c is our new point that we're doing that. Okay, so we've got y equals 6, the quantity x minus 1/2. Well, is that true? Well, I'm looking at the point. What point am I going to use? Let's put that down. Let's say this right up front. We're going to use what point? Use the point 1/2 and what? If I put 1/2 in there, I get 2. Yeah, let's use that. So, yes, it would be x minus 1/2 plus f of 1/2, which would be 2. The equation of our line is going to be y equals 6x minus 1. Now, how are you going to show that to me? You've copied all this down. If you're like most of us sitting in a class, most of our attention is making sure we get all the notes down. The brain hasn't gotten engaged yet. So, I need to pull us back now and say, so what? Okay? So what? Show me what you really understand. So graphically, draw me a graph that illustrates what you know about this problem. On the curve, right? Okay, let me just show you what I'm seeing here. We got a lot of people here. Let's see if we can pick out, some of you who don't have it, let's see if we can pick out the ones that are good. Here's an example. This is just a line. This one over here. Kind of like, so what? Okay? What does that line have to do with the problem we're talking about? But when I see a graph like this, how do these two differ? This is just a line. But this is trying to show me more than just a line. It's trying to show me what? And in fact, these two, I asked these two people to use a better window, and you want to do that in order to let me see exactly what you're doing. How do these two show me the problem? What were we supposed to do? Determine the equation of a what? Secant. And a secant is a what? Okay. Do you see 2 points on this curve? Yes. Did that person put those 2 points on that curve? Looks like it. They're not just any 2 points, they're the 2 points we want. Okay. Now, what's missing down here is I don't see coordinates labeled. I need to see those. And they should be the 0 or the 1/2 and 2 and the 1 and 4. Okay. This person even went in and did some little attribute, making it a different type of line.